In this tutorial, what we're going to do is take a look at moving closer towards making our very own game using PyGame. On the top of the week 8 page, there's a video of what we're ultimately going to try and work towards. So rather than watch a video of me watching a video, we'll just skip past that and you can watch that a bit later on. So what we're going to look at today is this idea of being able to see how close our player is in our target shooting game. I want a game where a character is going to appear on the screen at a random location. The mouse pointer will be a little targeting reticle, so we can try and move over the top of that, click the mouse, it'll play a sound, I think perhaps, and then you'll get a point, and then the thing your target will move somewhere else on the screen, and you've got to click it as many times as you can in, I don't know, 10 seconds or something a bit like that. That's the sort of game I want, a real basic chase the target type shooting game. So in order to do that, we're going to have to use Pythagoras' theorem, and hopefully you're familiar with this from maths. The idea is there's that a squared plus b squared equals c squared, and while that might not immediately appear obvious as to how we're going to be able to use that in target tracking, I'm hopeful that by the end of this tutorial you'll have a much better idea. So we'll come back to this. Let's start by writing some code, I think. The first thing you're going to need to do today is to pick up some resources, and I've got all the resources here on this download it and code it section. So I'm going to start right now. I'm going to need a copy of the template that we always use when we're doing PyGame. So I'm going to right click on here and I'm going to go to save as, and as I've done many times in the past, I'm going to go into my H drive, into computer science, into year 9, into PyGame, and today we are in week 8, so I'm going to call that week 8 template. A bit like this. You're going to want to keep this file as well after you've done this lesson, because you're going to use this again and build on it as we add the extra features into our games in the subsequent lessons, so make sure you don't delete it later. We also want some sprites. I've got a couple just here, so I'm going to right click on the bird, save image as, and what I'm also going to do, because this could start to get a bit chaotic otherwise, I'm still in H, I'm still in computing, still in year 9, still in unit 9.4, but I'm going to make another folder. Okay, I've actually already got one, but you need to call that folder IMG, this one just here, IMG, and we're going to place our image files in there. So here's me going in there. Again, as you can see, quite a bit of a practice, so I'd save that one, and that'll save in there, get hold of the targeting reticle, save to, as, once again into the IMG file, and I'll save that in there. So I've got 2 files that I'll be able to use for graphics. So what's the process we're going to try and go through to start to create our game? Well, before anything else, given that we know we're going to want to use some graphics, what we're going to need to do prior to starting the game loop is to set up some variables that we can come and use a bit later on. So I've got this game state equals running. You don't actually need that, it's the lines underneath it. It's these ones just here. So I'm going to grab these lines and I'm going to copy those. Boink, because this is already in the template, you see. And now what I'm going to need to do is load up PyCharm and get my my file open for the day. So let's go into PyCharm. Let's pretend I hadn't already done this. Here's PyCharm loaded up. File, open, into the H drive, into computer science, into year 9, into PyGame, and down here somewhere, week 8 template. Click, click. Alright, so that's loaded up, and let's just make sure before we do anything else that it's working today. So I'm just going to go run and run like this, week 8 please, and give it a few seconds, and if we're in good shape, if we're going to be able to code successfully today, after a few moments you'll get that big empty black PyGame window all ready to put more code in. So the code I've got on my clipboard at the moment is going to go just outside the game loop. There's that game state equals running line. Look, I want that my code to sit, I think, I'll pop it just under there. Paste, Control V, and that's going to sit here. Let's turn line numbers on as well, because that's going to make everything a little bit easier. So I can right click in that grey space, choose show line numbers, that'll do that. And at the moment I can run the program again, but what does it actually achieve? Well, at the moment not a lot. I've told the computer to remember some things, but I haven't actually told it to do anything with them. So let's have a look at these lines. Player 1 image is going to be me asking PyGame to go into the image library to load an image into its memory, not to draw it on the screen, and the image I want is the one in the image folder called crosshair, and the same idea then for the bird. So those 2 things are loaded up, and it looks like I'm storing some coordinates here for the X and Y position where I eventually want my target, my bird, to appear, but I haven't asked to draw it yet. That's going to happen in this game loop. I'm probably going to place some code in here. Let's think about the next step. So back to my web browser. So what I'm now going to do is use the idea that I had previously to pick up the mouse position and draw that targeting reticle that I've got, which I'll refer to as the player. And then what I'll also do as well is make the computer draw my target, my little bird thing, and we're going to draw that on the screen at a particular location. So if we look what we've got here, I'm saying first of all paint the screen pure white. What I'm then going to do is I'm going to grab the position of the mouse on the screen. I'm going to call that mouse pos. And what I'm going to do is I'm going to say the player 1, as in the targeting reticle, player 1's X position is going to be wherever the targeting reticle is on the screen, minus 50 pixels, because that targeting reticle, if you load it up in Photoshop or something, you'll see it's 100 pixels wide and 100 pixels tall. So you may remember from a previous lesson we centered up images, didn't we, when we did it with the GIMP thing a couple of lessons ago. It's the same idea as that again here. So I'm doing that for the player's X and Y position, and then what I'm finally doing is a bit of painting onto the screen. So I'm saying that I'd like the target to be a blitted version of the target image, which is the bird, and the bird's going to be drawn at target X, target Y, which I'm pretty sure is 100 and 100. We set that up earlier on. And then what I'd like to do is I'm going to have the targeting reticle drawn, made from player 1 image, which is the targeting reticle, and I'm going to place that at player 1x, player 1y on the screen, which is wherever the mouse happens to be at that point in time. And I'm going to ask the computer to do this 60 times a second. So the illusion will be that as I move the mouse around, the targeting reticle will slide around with it. So let's grab that bit of code, plunk, into PyGame, into the game loop, and that line of code's going to sit here in about line 30. Let's paste that into position. There it is. Make sure when you paste it in place, this has done it automatically, which is lovely, but do make sure that all the code is indented in the screen. So you don't want code where all the lines tucked against that left edge. You've got to make sure that you use the tab key just to push that into the screen a bit like that, and that'll sit there properly. Right, well, let's have a little go at running that and see how we do. So I can use play now. Dun, 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 dun. Here it comes. And there you go, there's my targeting reticle. Look, it takes a few seconds to catch up, but you can hopefully see that once it settles, the targeting reticle sits dead center on the mouse pointer. I should probably hide the mouse pointer at some point. And there's my birdie there, all ready to play a game of trying to hit some targets. So what's next? Well, let's have a look. The next thing we need to establish is whether or not we've actually hit the bird when we click the mouse button. And the only way we're going to do that is by using our old pal Pythagoras. If you imagine the way the computer sees this, because the computer doesn't really see a bird per se, it just thinks about a set of coordinates. It knows this point on the screen here, 100 across, 100 down, I think we drew it at. So it understands that, but we recognise hopefully as a player that if I said the only way you can be classed as clicking on this bird is if you click exactly on that dead centre point with a tolerance of 0 pixels, it's got to be pixel perfect, otherwise you haven't hit the bird. You'd never hit the bird because no one's going to be that accurate, and it'd be very frustrating. What would be better would be to imagine from this point, to imagine an imaginary circle going out around here, something like this, of a particular radius, yeah? An imaginary circle like that, and to say that as long as when they click the mouse, they're within, I don't know, what about 25, 40 pixels, something like that. As long as they're in that sort of radius, then actually we'll say that they've managed to click on the bird, and we'll allow that to happen. Well, we can use Pythagoras to solve this, because actually what you've got here is a triangle problem. So let's look at what we've got. Here's my targeting reticle. I'm going to treat that as 1 point in a triangle. Here's the bird. I'm going to treat the dead centre of the bird as also 1 point in a triangle. And I can form a right-angled triangle from the other 2 points. So what I can then do is, given that I can calculate this distance here, because I know that from here to here is 100 pixels, so I know that. Given that I know this distance just here, and that just depends on where the reticle is, but let's for argument's sake, let's say that was 200 pixels from the top of the screen, so it's 100 to here, 200 to here. I can do that number minus that number, and that gives me that length, just like you did in a maths lesson. So that's my value for A. I can do exactly the same thing for B as well. I know, because it was me that drew it, I know that that bird is 100 pixels from that edge, and I also hopefully know, because I read it and stored it in my program, that at this point here, and again we'll just use the same number, but let's say at this point in time that's 200 pixels across. So if I do 200 minus 100, that tells me that distance there. And if I've got 100 and 100, I can solve, using Pythagoras' theorem, a squared plus b squared equals c squared, I can solve that and I can find that distance. And if you imagine applying that same idea for lots of different points, you can start to imagine drawing sort of a curved idea to get that radius idea that I was looking for before. And that's what we're going to try and do. So what does that look like in terms of code? Well, it turns out in order to be able to solve Pythagoras' theorem problem, you may recall if you've done it before that you need to be able to use square roots. And unfortunately, by default, Python doesn't support square roots. So we need to import some extra ability into Python. And so that's why we're going to add a new line, which is this one here, which is import math. It's an American program, that's why it doesn't say maths. Import math. That's going to bring in some extra capability into Python. And specifically what it does is it gives us access to this square root command. So we're saying that from the math instructions, I'd like to do some square roots. So let's look at the code we've got here. What we're also doing is we're creating this thing called a function, which you might recognize as well from the previous lesson. So again, everything we're doing today is tied together from elements from previous lessons. So I've got this idea of Pythagoras' theorem, that's my function I'm creating, and I'm going to send in the player's x position, the player's y position, the target x position, and the target y position. And using those exactly how I described here, I can then perform and get the value of c, which I can print out onto the screen in the short term. We'll do something more sophisticated with it later. So just like I described, I'm saying that in order to get the value for a, it's the player's x position, take away the target's x position. To get b, it's the player's y position minus the target's y position. And then to get c, it's a squared, this means to the power of, let's say you write that on a computer, so a squared plus b squared, and the result of that, see it's wrapped in brackets, square rooted, gives me a value for c, which we're going to print onto the screen. So let's take that code and let's chuck it into Python. So that's going to sit right at the top of our program up here. I've actually got some other import statements already. There's me bringing in PyGame. There's me doing something to communicate with Windows a little bit. That's just folded up for neatness. And I can just take my code that I've just picked up and I can paste that into position just here. There it is, import math. There's my function. I'll just give that a little bit of a new line in there just to clean it up and make it look neater. So there's my function. But remember, just like in the previous lesson when we did text, writing the function definition doesn't actually make it happen. It teaches the computer how to do it for when I might want to use that code. So I need to, as we say, I need to be able to call that function. So let's add that function call into our code. We actually want to do this and print it out over and over again inside a game loop. We're going to want to do this on a fairly regular basis. So I'm going to grab this just here. This is me calling it. This is me feeding in the instructions I wanted. So I'm just going to copy that code. And what I'm then going to do is to take it, I'm going to paste that in here, in my game loop, right down at the bottom. I'm going to make that the last thing that I do once I've set up all my other variables. So let's run that and see what it looks like. We haven't got the ability to click and to shoot at targets yet, we haven't got that, but what we should get is lots and lots and lots of numeric data printed onto the screen to tell us the value for C, to tell us whereabouts on the screen we are. So let's click play and have a look at that. So program loading up, and I'm just going to drag this out the way so you can see it. And what I want you to do is just look in that bottom corner. You see down here, look at all this data coming in. And that's every single time that the loop runs, what it's doing is it's doing a squared, b squared, c squared, it's performing Pythagoras' theorem, and then it's telling me the value of c in my shape. So as I get this target now, as I move it closer to the bird, you'll see that number is going down. And that's how many pixels away the center of the target is from the center of the bird. And it's going down, and it's going down. We're almost on target now, look. Almost going down, and there we go, we're about there. So actually, when I write my game later on, what I really want to say, I suppose, when I'm trying to work out whether or not I hit the target, is I want to be able to say that if I'm within about, I don't know, 0 to 30 pixels or something like that of the bird, then I should be allowed to say that I've hit it when I click the mouse button on it. So we're going to be able to use that data in our next lesson to start to form that up. So, what are you going to do? Well, the badge tasks for this particular session are these. The first thing I'd like for you to do is to go through your code that you've done and to comment it. So at the top in that function definition, you'll write something in there. You can write something next to that import line. You can write something about where we capture all the mouse coordinates and square everything up. So it shouldn't be too bad. You don't need to write big essays. A few words next to each line would be great. The next task after that for you is to then try and recycle an idea from a previous lesson. And that was the one in the text me lesson where we were able to make labels. And what I'd really like it to do is to, rather than show it in that console window in the bottom corner, I'd like to have text written on the PyGame window, like I've got in this picture just here, and it tells me that number. I know it's a lot of decimal places, and you might even be able to find out how to round numbers down to one decimal place. That'd be a nice little extension task. But see if you can do that and make the text appear. Final challenge, the platinum one, is going to be use the PyGame draw line feature, the function, to actually try and draw the sides of our triangle that's being formed. So as I move my mouse around, it constantly draws a new triangle. On the face of it, that sounds desperately difficult. But just like any computer science problem, if you actually take a little time and you do a little thought around it, you may find it's not all that bad. One of the reasons that it's not too bad is that if you take just a single step, which is to draw just one line, like this vertical one just here, you might be able to try and work out, using the line code, and think back how it works. So for example, when you do draw a line, what do? You give it two sets of XY coordinates. You need to say where to start, you need to say where to end. And perhaps your program already contains all that information, and it's just a question of using that line to be able to do it, and giving it a colour to draw it to. That's an interesting little problem, and so I'd really encourage you to have a bit of a go at that. Always remember when you're trying things as well that there's no worst case outcome. You're not going to break anything or damage anything, and if you save your code before you start experimenting and put a backup copy somewhere else, if you do make a mistake and your code gets to a point where it won't run anymore, you can always pick up another copy of it and start trying again. So there is no worst case outcome. So again, I really encourage you to have a bit of an experiment. Anyway, I'll see you in the next tutorial.